Stan Zareki here to demonstrate the functionality of the collector robot I have designed for this project. Starting with the basic layout of the schematic, this is drawn to roughly represent physical reality with four independent motors at the corners here to represent the four wheels. Vehicle forward is on the right. There are four distance sensors for each of the cardinal directions around the vehicle, checking for objects. In this case, set to a minimum clearance of 24 inches. There's a battery bank here to power all the various motors. And then down here are two servo motors representing function of the dump bed to empty the main bed, as well as the claw. Commands are given through the number pad via the serial monitor. So we'll see here if I enter an 8. It's a little small, so I'll zoom in. Motion on all four motors is in the forward direction on all four corners. And that is because, or it is allowed because the distance on the center exceeds the 24 inches I had mentioned earlier. Now, if this drops below, you'll note all motion stops on the motors as an object has been detected. Once the object is clear, motion doesn't necessarily resume. That will require additional input. Again, saying forward again, and you'll see the motors kick back on in the forward direction. Similarly, if I input a left-hand turn using a 4, we'll now see that the turn is executed by turning the two left-hand motors in reverse, the two right-hand motors forward. And similarly, in switching to operating the dump bed and the claw, in this case we've coded 7, operates the claw. We'll see the motion moves in one direction, and then basically placing the trash into the bed and then resets to the home position. You can do the same thing for the dump bed, tipping the bed, emptying it, and then resetting back to the home position. Code is shown here on the right that runs the two servo motors, very similar to the examples shown in the course. Going to the main chunk of code, this is operating all the wheels, the directions, the controls, and the distance sensors. Up top, we have all the various definitions, our setup where we set all our pin modes, establish serial, read, and then define, for the sake of cleanliness in the code later on, a number of helper functions that just simplify things down below because they get reused a number of times. This first one, this is just to read the distance from a given sensor. Given that there are 4 different sensors here, it takes in an input of what the trigger pin is, as well as the desired echo pin, and returns the distance as a float value. Then there are 5 different motion functions here. First one being stop, setting all motors to no motion. Forward, putting all motors in forward. Right turn, left turn, reverse, and then the main body of the code, which functions basically by taking in either an input via the serial read command and then parsing what to do with that input if it's a valid input, as explained in 8, result in forward motion, 4 left turn, and so on. And in that code, it's checking to verify if the distance from the appropriate sensor is clear. If so, it makes the move. Otherwise, it will not move. If no input character is present, it just continues on with the existing motion, which is handled down in this lower section here. And again, it's broken into sections for each of the various directions: forward, left, right, reverse, and then no need for a stop in this case, because once it's stopped, nothing's happening. And that covers the collector robot. Thank you very much for your time.